Hello everyone. So today we are going to implement grenade throwing capability for NPC characters. So in the behavior tree, sometimes they, with the probability, they throw a grenade when they are in a fight towards their enemy. So here I have increased the probability of throwing grenades to demonstrate the effect. See, these guys are throwing grenades all over the place. Actually they are throwing at their enemies. So this is the demonstration. So let's see how to implement this today. And this episode is sponsored by these generous patrons. Thank you very much for your support. Right, so far we have implemented ability to throw grenades for the player character. As you can see, we can aim and throw grenades. So like that. So but I have only enabled that for the player character because the grenade throwing function is implemented through an input action. So let me show the place where I have implemented this in ALS based character. Under this grenade throwing part, we have this input action throw. So when I press G, this animation plays and arc projectile path appears that predicts the path of the grenade after throwing, and when I release the grenade button, it plays the rest of the animation and throw the grenade. Since this is associated with throw input action, we can't really use this to throw grenades for NPC characters through the AI. For that, we gonna need another function or an event that can be called from the AI. So to be able to call from AI, let's add the function or an event to this 𝐂𝐿𝐴 character interface. So I'll call this function throw grenade, and we need an input which says the target location that we need to throw the grenade. So target location, it should be a vector. Right now, the reason I implemented it through the interface is to be able to call throw grenade function without having a concrete reference to this ALS based character. So we can just call it through the interface event. So let's implement throw grenade. Now as you can see here, from 𝐂𝐿𝐴 character. Now just like before, all we have to do is play in the exact animation montage which has the grenade throwing action, and when this notify begins, we have to so since unlike the player character, NPC characters don't have to hold in the aim position and throw. They can just throw the grenade because they are AI characters, and there is no need to give some more time to allow manual aiming or something. So I can use this same function with this same animation montage, but let me promote this to a variable so that I can reuse the same variable when I play the montage for the grenade throw event. Anim throw. I'll put it under throwing category. Compile, and here also I'll use that reference from now on. Compile, and now we need to make sure, let's go here and check if that animation is set for this character. So it's not set. Let's reset. Now it is. Okay, let's quickly check if that change is applied to it is applied to the NPC as well. Alright, so now let me copy this part. Oh, actually no need to copy, let me just do it. Let's call play montage this function, and input skeletal mesh is the character mesh, and input montage is throw. And when the notify begins, we need to spawn a grenade and place it in the hand of the character, and we already do that part here, so we can reuse the same thing. If I convert this to a macro, collapse to macro, let's call it spawn grenade. I'll connect this to the output so that we will have an output, execution output in the macro. We will need that. So basically what it does is get the grenade socket location of the mesh, which is near the left hand, and spawn a grenade actor and attach it to the grenade socket. That's basically what we do, and set this pp grenade variable. Right, now I can use it. Where should I use it? Let's use it here. Spawn grenade in on notify begin, and then we need to play the rest of the montage just like we do after releasing the grenade button. But for the NPC we don't have such an event, so what we can do is do the same thing. Starting section is end. So when this animation is playing, what we have done here is after 0.3 seconds we throw the grenade. So here also let's do the same thing. Let's add a delay of 0.3 seconds, and let's check if we have a valid grenade object. If yes, we can call throw event. Right, but the problem is how do we calculate the velocity? That's the next problem. and as an input we give this target location. So we do have the target location here. From this we need to calculate the velocity. So let's collapse this part, this node, and name it calculate velocity. Okay, but this, so all this does is just returning the same value, target location, as the velocity. So now let's see how can we implement this. Right, so if we consider a projectile which goes like this, let me use a different color, goes like this. So this is the starting position and this is the end position. So in the middle, let's say the amount of time taken to reach this location, this desired location, is t. Then here it would be t divided by 2. Pardon me for the unclear diagram. T divided by 2, right? And this distance would be the distance of the two vectors. Here is the actor location, let's say A, and this is the target location, let's say B. So the distance in the horizontal plane, that means along x and y axes, would be this distance, let's call it S, and this height we don't know. So when we consider this start initial velocity, let me call it capital V, no, yeah, let's say capital V, no, just velocity. This have two components, the horizontal component and the vertical component. Let's call the horizontal component U and vertical component V. So we have a few basic equations regarding this linear velocity that we have learned in school. S equals ut plus half at squared, and we can calculate S here because we know the character's location and the target location. So from this equation, if we apply this equation to the horizontal part, we can calculate U using like this. From if I we can convert this equation to this, U equals S minus half at squared divided by t. Right, now we know U, which is this, okay, the horizontal component of the velocity we need, and V. So at this top point we know that vertical component of the velocity becomes 0. That's why it stops going up and continue to come back to the earth. So we have another equation. Let me change the color. V equals u plus at. Now don't mix up this v and u. U means the initial velocity. This u means the initial velocity. A means the acceleration. T means the time. Now if we consider this time, v becomes 0 because at this point there is no vertical component of the velocity. So that's why it's flat. So 0 equals the initial velocity. Initial velocity is this v. So this v is this v plus at. Now if we bring v here, v equals minus t divided by 2, because this is this. I hope that the explanation is clear. If not, you will have to research a bit about the projectiles and velocities. You should have learned this in your school. Right, now we have a way to calculate v and u. So this velocity means v plus u. So we have the vertical component and we have the horizontal component of the velocity. Put those things together as a vector and we have the velocity we need. So how do we do this calculation in blueprints? Right. Okay, so we have the target location here and we can get actor location. So if I do a minus, if I subtract target location, the actor location from target location, we get the difference between the actor location and the target location. So from here, if we calculate vector length, so this one would be the distance between the actor location and the target location, but this part contains the vertical component of the distance as well. But if I want to get this s, which is the horizontal distance, what we can do is split this and consider only x and y. So this is s, or in other words, horizontal distance. Okay, so let's just assume that if the target is 1000 units away, the grenade should be should reach the target location within 1 second. So let's use it as a requirement. So then if I divide this by 1000, I get this is the t, which is the time taken for the projectile to go from here to here. So this is the t. So now we have our s and we have our t. and using this equation, we can calculate v, and using this equation we can calculate u. And here acceleration is gravity, so v equals minus a, or we can call g, t divided by 2. So we can multiply this by minus 1 and gravity divided by 2. So to represent divided by 2, I can put 0.5 and gravity. So let's make literal float. So gravity is minus 980 in Unreal Unix. Let me put that here. So here, from this result, what we get is v, which is the vertical component of velocity, right? And now we have our v. So this is just a value, but since this is vertical component, this can directly put to z component of the velocity vector. Now the next thing we need to find out is u, which is the horizontal component. This is vertical component, horizontal component of the velocity, and we can use this function. So we have s here, s minus half velocity t squared. So this half velocity t squared, half 0.5, and velocity we have here t squared. Let's add another thing, square, and put it here. So now here we have s minus half gt squared. That's what returns here, and from this we have to divide again t. So t again comes here. So now the result of this node is u, horizontal velocity, but this is a float, so what we get is the magnitude of the horizontal velocity. Right, now to calculate the required velocity, let me split this. We have the z component here, and x and y component should come from here, but still we don't know the direction, so we can calculate unit direction vector from actor location to the target location, and we can make vector. Now we can multiply this with a vector. Multiply vector. Right, so we can split this and get the only the x and y component, which represents the direction in horizontal plane, and multiply this by this magnitude of the velocity. So here we have x and y components of our required velocity, like this. Okay. Alright. Now we have the required velocity. I think that should be right, but we need to test this. So to test this, now let's look into the AI component. We need to call this 𝐻𝐻𝐺𝐻𝐸 function from the AI character. So for that, here let's go to the behavior tree and go to the shooting part, and here before we start fire, let's only for testing, let's ask the character to always throw a grenade before start firing. So for that we need a new task. VT task, print base, let's call it VT task throw grenade. Right. Now execute event receive execute AI. So here we need to know the target location. For that, let's add blackboard key target actor. This should be public and type should be a blackboard key selector. We can get the target actor get value as actor. Right, now just to be safe, let's call a is valid function here. If yes, if we have a valid actor, we can get actor location. So, and then we can get a reference to controlled pawn. Let's call throw grenade using this as the target location. And in order to throw the grenade, the character will need, let's say, what's the length of this animation? 2.67 seconds. So let's get a delay of 2.7 seconds here, and then call finish execute with the success. Otherwise, let's call finish execute with the false. Actually, even if I call it success, it won't matter here. Right, now let's add this here. Throw grenade. Okay. And we need to pass the target actor. Alright, shall we test this? So once they detect an enemy character, they should first what they should do is throw in a grenade. Let's simulate. Yeah, they are throwing a grenade, but they threw the grenade, but for some reason the velocity is not enough. What's wrong? I guess my calculation is wrong here. Actually, this should be positive 0.5 because here we have the minus mark. So therefore we don't need to mark this one as minus. Let's see. Right, but for some reason the grenade overthrows the target. What's wrong? Let me make this half. This is the gravity. This is just a test. Nothing. There is no reason. Now it works. But how? Let me pull this character further away to see if it still works. Yeah, that actually works, but I'm not sure why this should be half of the actual gravity. Maybe I lost something in the conversion of the units. But hey, it works. So yeah, let me know if you found out the reason for this to be half of the gravity. I'm not sure at this moment, but I need to look into this later on and I will tell you if I find the reason. But anyway, since this is working, let's keep it, because the AI characters can find the target location and throw a grenade. So now what I want to do is, it's not good if the characters are always throwing grenades. So what we can do is, we can give a random chance to throw grenades. So if I, here let's add a branch, and if I make a random move, so if I do it like this, there will be a 50-50 chance to throw a grenade, but that is also still too much, you might think. See, sometimes shooting, sometimes throwing grenades. So we need to definitely reduce the chance of throwing a grenade. So what we can do is random int in range. So let's generate a random number in between 0 and 100, and let's say we only need to have a chance of throwing a grenade, let's say 30%. So if this number is less than 30, throw a grenade. So this exactly gives us a 30% chance. If I make it 20, it would be 20%. If I make it 100, it would be 100%. That means always throwing a grenade. So you get the idea. Let's try now. So now we should see more shooting, and no. Why is that? Why are they always generating a number less than 30? Let's print the number we get here just to see why do they always shoot throwing grenades. Right. So I guess what happens is this part is always calling. Right. So should we, so this part will be called again and again until this succeeds. I think that's what happens. So let's finish this with a success then. Right, now it's working with the correct percentages, but since for testing I have reduced it to 1%, we don't get much chance to see a grenade throwing. So if let's reduce it to 30. Oh, that's too much. Let's say 5. So here is the final preview. I have increased the probability of throwing grenades to 30%. So they are now throwing grenades more often. See, this is a grenade. So yeah. Let's see if anyone else throws a grenade. Yeah. Great. So I'm gonna stop this episode here. So now the NPC enemies can also throw grenades. So you will have to optimize the probabilities when to throw grenades. We can fine tune those AI choices later on. And thanks for watching. So as always, project files will be available here for the download. Link could be in the description below, and if you like to support my work, you can get the membership of the Patreon Club. See you in another episode. Goodbye.